All right, guys, it's time to update this greedy algorithm problem. So the original ChangeMaker assignment used to use arrays, but we've since brought that back down to method making. And I'm going to update the video. Greedy algorithms are really interesting because they just keep doing something so long as they are able to do it. ChangeMaker, a lot of cash register problems do that. You could also find this useful for Roman numerals and so forth. But let's go ahead and look at the problem. So we are going to make a cash register problem, and we are basically going to do all the math so that they know exactly how many pieces of data to, or how many pieces of coinage and bills to give back to the uh, the shop. All right, very simple layout. Ask them how much is your bill. Ask them how much they pay. Call a method, and then get it to print all this other stuff. Now, because there's so many different variables going on, this is going to be a void method. We're going to do all our calculations and our printing in one go down at the bottom. You'll need multiple variables. Yes, we will. Because arrays. And yep, off limits for now. Okay, so yes. So let's take a look. I got my skeleton set up. We're good right here. Main method's very simple. We're just going to ask the questions. I've already got my scanner. How much is the bill? Make me a double. Now do the same thing. How much did they pay? Or not you, they. All right, and then this will be pay. Okay. If I want to, I can space it out, but this is fine for now. And then now I need the method call. So, because everything is going to be done down there, I just send those pieces of information to it. It's going to error because, again, the method doesn't exist yet, but that's my entire main. Pretty straightforward. All right. Now I come over here, public static void ChangeMaker. Now I need to do my full signature, so I need to redefine my parameters because those are going to be my local variables here in this method. So they're both doubles, and I'll just keep them exactly the same. You can change the variable names if you wish. Just be aware how they match up. Now, when you're doing method parameters, the order matters as long as data types match. So bill and pay in that order are both doubles, so I have to be very specific down here as well so that they match and line up. Okay. Same thing like with rubber ducks, where some people accidentally mixed the order the strings were in, and that threw off your end result. Okay, order matters. All right, so error went away because it's a void. There's no return required. So now we just talk about how we do this. One of the things a lot of people have been having troubles with, and the reason why I updated the assignment when we graded and said it was okay to be within a penny or so, was because there's rounding errors. Okay, y'all remember when we talked about doubles initially, every now and again Java would throw out a random tiny decimal. So if we said A is equal to 5.0 and we printed A, Java might print 5.00000000000000002. Okay, that goes with how computers and electronics store values with decimals, and that is something we do have to think about. Now, the way to avoid it entirely is to keep track of just integers. And in order to make sure there's no rounding error, before we even do the math to figure out how much the change is, we're going to shift everything into integers right now. Okay, so let's do this. We'll just call these 2 of whatever we're using. So bill 2 is equal to, I'm going to cast it, bill times 100. Okay, I'm going to do the same thing for pay. The casting makes it behave like an integer. Ooh, I need to make sure that I get the multiplication first. And then this way it'll cut it off so that there's no extra little things when we mess with it. Now that is going to increase our values. So like $20 is now 2,000. So be aware, when you do this, you're shifting your amounts. And so now we're ready to calculate the change, which is where we go pay to minus bill to. That's it. So now we've got integers. We're good now. So now we just need to do the whole operation. And that's just lots of variables and lots of math. Okay, it's simple math, but it's repetitive because you might give them multiple 20s, multiple 10s, multiple quarters, multiple pennies, whatever the case may be. So the way I like to do it is I'm just going to do while loops because these are just simple to me. There are ways of doing this with mod and division and so forth. Nothing wrong with those. Again, you just have to be very careful of your data type arithmetic. Ints give ints, doubles give doubles, and to make sure we have no rounding errors, we're going to stay in ints. So while change is greater than or equal to 2,000, because remember that's my $20 now. Okay, I need a variable int twin. Just keep them in 4 digits, so it's or 4 letters, so that's easy to see. So 0. Twin goes up, and change minus equal 2,000. Okay, and yep, that's good. And now I can just print that out. So the $20 has this many. And that's pretty much my entire cycle. So I'm going to do this for every single denomination that we're asked to create. So like for the tens, I do the same thing. Tens are 0. $10 is 1,000. We just have to update all the basic information. Okay. After tens, I got fives. $5 is 500. And I'm lining these up just so that they are straight lines. Ones is 100. Okay, now there's all my dollar bills. Okay, now I keep going with the change. So first I've got quarters. That's good. So a quarter is just going to be worth 25. Then I have the dimes, which are worth 10. Then I have the nickels, worth 5. And then lastly, I have the pennies. Now the pennies are a little bit different because that's our end, so we don't actually have to manipulate anything. Just to keep the variable, we could say that is the change. So I've got 1 cent. Okay. All right. So as you can see, pennies is much abridged. Everything else is identical. Yes, when you get to arrays, these are a lot easier. You can mess around with them. I chose not to. That's okay. Um, so let's go ahead and give it a shot. We've got sample values here. $13.44 out of 20 is $6.56. Okay, 13.44 paid out of 20. 5, 6, 50, 5, and 6 cents. There you go. So, again, greedy algorithm just means it keeps doing something while it can. That's why I've got while loops instead of ifs, because I want to make sure some of them were ones, but they don't always have to be. Hope this helps, and y'all have a good day. Bye.